We're going to talk about a little higher degree polynomial today, and what can we do to factor it. Taking a look at it, x to the third minus 7x minus 6. Can't use a quadratic formula. Can't complete the square. Can't use the Xbox method or any of your little tricks up your sleeve to factor a quadratic. We need something else. It's not the difference of squares. It's not the sum of cubes. It's not the difference of cubes. It can't factor by grouping. We have all these little tricks in our toolbox. We've learned so many things since 5th grade on how to factor something. This is a little different. I want to introduce this process called synthetic division. What we're going to do is take these coefficients off. We're going to think about some possible roots, and we're going to learn this new process here. It's called synthetic division, or quite possibly coefficient division. To start, what we're going to look at are our possible factors. Think back to your quadratics. We looked at the multiples of 6. If we look at FOIL, the old infamous FOIL, the lasts, when we FOILed something, it had to multiply to 6. That's going to be the same little process here. It's a little bit different in that we're going to take all the factors of 6 and divide it by all the factors of this lead coefficient. The lead coefficient is 1. As such, possible solutions are positive and negative factors of 6 and 1. That's plus and minus 6 over 1, plus or minus 3 over 1, plus or minus 2 over 1, and plus and minus 1 over 1. All of the possible numbers that might work in here. Not all of them will work. And in fact, only 3 of them might work. It might be a repeated root. 1, 1, and 1. 1 might work all 3 times. Negative 1 might work all 3 times. Might work twice, and then another number might work. These are the only possible numbers that could divide into this synthetically. What that means is this. In various books, you're going to find various ways to do this. This is a very general setup of synthetic division. Here it goes. We're going to build a little tree house. We're going to now list the coefficients. 1. This is 1x to the third. What happened to x squared? There's no x squared term. We're going to put a placeholder. We're going to put a 0. Anything that might be missing, we're going to take into account, and we're going to put a 0 in for it. 1x to the third. 0x squared. Minus 7x minus 6. We're going to list the coefficients. We're going to build a little tree house. We're going to leave a space, and we're going to put a line. That's the basic setup of synthetic division. We're going to build some factors here. We're going to test numbers. Let's test 1. Let's start at the bottom. Let's not go for the big stuff. Let's go for the little stuff. Let's take the factor 1. Let's give it a shot. The process of synthetic division is as follows. 1 plus nothing. We're going to add straight down these columns. We're going to add something together. Well, 1 and nothing is 1. From here, we need to put something here. Here's how this goes. 1 times 1 is 1. Again, one more time. 1 in the treehouse times 1 is 1. Add straight down the column. 0 plus 1 is 1. Multiply again. 1 times 1 is 1. Add straight down the column. Negative 7 plus 1 is negative 6. 1 and negative 6. 1 times negative 6 is negative 6. Negative 6 and negative 6 is negative 12. What the heck just happened? We tried 1. It does not go into it evenly. We want to make this a 0. We want to somehow create this last column a 0. It's not a 0. It's definitely quite okay. It just means 1 is not a factor. Instead of on your paper scratching it out, instead of getting just all disheveled here, we're going to take an eraser. That's all it takes. I'm just going to erase what we did. We're going to pick the next logical solution. Not 1, but how about negative 1? We're going to try it one more time. 1 and nothing. Multiply. Negative 1 times 1. 0 and negative 1. Multiply. Negative 1 and negative 1 is a positive 1. 7 and a positive 1 is a negative 6. And all of a sudden, negative 1 times negative 6 is a positive 6. add straight down the column, boom. Once we have a 0, that means it's a factor, that means it's a 0, that means it's a solution. This is a solution. I'll tell you what that means here in a second. What does this mean now? That's our next goal. This was an x to the third. It was x to the third. It was x to the third here, and we took off one solution. We took out an x, actually. If we have an x to the third, and we factor one x off, boom, x squared. We take an x to the third, we factored one of the solutions off. This new coefficient is actually the coefficient of our new polynomial. One more time. X to the third. We took off an x. X squared. Drops to x, drops to negative 6. New coefficients. You synthetically divide one of these possible solutions. Not every single one's going to work. It's going to pop out a polynomial here. It's going to pop out a quadratic. You guys have factored this probably 1,000 times in your life. Putting this all together, you had our original polynomial. We tested numbers. We tested a 1, it didn't work. We could have tested a 2, we could have tested a 3, we could have tested a bunch of numbers. Some will work, some will not. Negative 1 worked. From synthetic division, we got this number, negative 1. What does that even mean? From factoring that x squared minus x minus 6, we got these two factors. How we build this and how we finalize everything and get this all done is this. The zeros of your polynomial x to the third minus 7x minus 6 are negative 1, positive 3, and negative 2. Your linear factors are x minus 3, x plus 2, and this one, x plus 1. You would not have been able to get x to the third minus 7x minus 6 down to these three factors by any other means but synthetic division. You could not have used the quadratic formula. You could not have used difference of squares or sum of cubes or factor by grouping. We need the synthetic division process or the coefficient division in order to factor higher degree polynomials that we can't rely on the little tricks for. From here, we can graph these x-intercepts. We can test end behavior. We can test for y-intercepts, and we can test for all sorts of things. Those are the types of things we're going to be doing in class tomorrow. I hope this helps.